Welcome back to Physics with Miyoshi. We're going to do a quick example for Newton's second law, and basically what we're going to find is the answer to the question. We're going to find the acceleration if we're moving, for instance, a vehicle that weighed 560 newtons and we were pushing it. Maybe two people were pushing, one at 275 newtons and the other at 395 newtons. We can draw our free body diagram. Again, I've tried to make sure all these forces are pointing in the same, they're all acting on this one body. And normally what I would do is I would add them as a vector. Well, let's put it over here a little bit farther. When we draw the free body diagrams, we try to keep our vectors proportional. Notice this is a little bit short, but that's okay. And I would normally put them, adding them up from one point. So maybe something like this is what it's going to look like. So first thing we're going to do is we're going to find our net force, and we can do that by doing the sum of our forces. And I'm just going to consider this to be east and this to be considered west. So I can now say that the forces are 275 newtons east plus, I'll just put a vector over there, plus 395 newtons east plus 560 newtons west. And if I think about that, my 560 newtons west, I could put that as a negative 560 newtons in the east direction. Now I can just add them up. 275 plus 395 minus 560. Let's just put that there, because they're all in the east direction. And that's going to give me a grand total of 110 newtons in the east direction. So we can see that our final, or our net force here on our mass is 110 newtons in this eastern direction. And it doesn't matter whether I call it west or east or north or south or whatever. I just know that it's in the same direction that I'm calling east right now. Now to find the acceleration, we just have to go back to Newton's second law and remember that our acceleration is the sum of our forces, or our net force divided by our mass. And in this case now so I can just write that equation. I like to write my equation. Sum of my forces. That's a terrible sigma. Divided by my mass. And in this case my sum, I already know that, it's 110 newtons to the east. Divide that by, yeah, it's not northeast, but it's newtons in the east direction. Divide that by my mass, which is 1850 kilograms. I will break that up into the newtons into kilogram meters per second squared. So this would be 110 kilogram meters per second squared in the east direction. Divide that by my 1850 kilograms. My kilograms divide out. I'm left with meter per second squared, which is an acceleration unit. So I'm left with an answer of 0.0595 meters per second squared in the east direction. So my acceleration vector is 0.0595 meter per second squared in the east direction. Simple application of Newton's second law. Just add up my forces, find my force. First of all, draw my free body diagram, put in my forces, label my forces, label what I know, just like I did with the kinematic stuff, and find my sum of my forces by adding them together vectorially, and then taking Newton's second law, A is sum of my forces divided by my mass, and doing that, knowing my vector goes in the east direction, it's the same as my force, same direction as my force, and finding the final answer. So, fairly simple application of Newton's second law in one dimension, and Thanks for tuning in. We'll talk about more Newton's law and how to do these things vectorially in more than one dimension next time on Physics with Miyoshi. Thanks for tuning in.